Yeah.
Oh, I love Snickers.
Oh.
I can't have Snickers. Well, how are you not? Why can't we have them sweets?
Oh, yeah.
I don't know. I'm about to. Thanks. Go. This has been quite a journey to get to this point. There's a lot of things that go into this. Did I have to make it take 11 weeks? I don't know, but I feel like we're really good at what we do. And this is good. This is some good, nice upper level-y kind of math stuff. So finally I can say, we got this. There are no gaps. It feels good to say you can do this, you could do this, you could do this, you could do all the things that are required to get through these. Ooh, that's really good, Kinsley. Thank you. So today we can finally find all zeros of polynomial functions, whether they're rational or irrational or imaginary. It's like, wah! So let's get to it. Got 5 examples. First one you'll recognize. And you should see why we've been doing what we've been doing for the last couple of days at various points throughout the lesson. So there's our function. How many answers will it have? Right, good job, guys. It'll have 3. Fundamental theorem of algebra tells us if it's a third degree, it's going to have 3 solutions. So let's get to it. Right, and I wanted to show you that synthetic division, so today's lesson, I wanted to be sort of a mishmash of sometimes it's good to do the rational root theorem. Remember that with the synthetic division, and that's not what we're going to do in this problem. Why? We recognize him. It's been a while. It's like you could say hello to him, but we haven't seen him in a while. But what is he? The short set, long set difference of cubes. So this isn't the type of problem where I feel like I need to break out the big guns. I consider the rational root theorem and writing a list of possibilities and guessing and checking. That's when we're really getting hard up and we're going big. But I don't need that for this. So what I'm going to do is I'm going to find A and I'm going to find B and I'm going to short set and long set this. Why not factor if we can? So A is X and you would agree that B is 1. It's been a while since we've short set, long set it. So what will short set be? And what will long set be? Plus 1x plus. Yeah, it's been a while, right? Welcome back to factoring, right? And there's one type I'm leaving out today. That's reserved for tomorrow's, or not tomorrow's, but Monday's assignment 20. I purposely left, you won't see any lookalikes today, right? Because that produces something that I didn't want to cover too much in one day. So lookalikes, basically everything we're talking about today, we'll just transfer over and talk about lookalikes on Monday. Super not hard, but I just, like I said, I didn't want to overload you. So there it is. There's our factors. And so I look at this now and I say, okay, since someone's asking me to find all the zeros of the function, then what they're saying is that these two things multiplied together must equal 0, right? We've had that conversation before. And now I can say that either the red set must equal 0 or the purple set must equal 0, right? That's just basic math 101. 2 things multiply to make 0. One of them better equal 0. What makes the red set equal 0? 1. So we can now say that one of the solutions to our equation is 1. And the reason I took a several-day detour was because of what you're about to see. Under normal circumstances, not normal, under a week ago circumstances, the leftover thing would have been factorable. You remember how like we did the synthetic division and the 3 numbers at the bottom would have been something cute like 1, -2, and -24. And you'd have been like, oh, it's easy. X minus 6, X plus 4. What changes now is that nothing in today's assignment is going to be fully factorable. I made sure I just kept asking it to make more problems until there are no freebies today. Like you can pull stuff out early. Like that was pretty easy how we pulled the one, right? That was light work. But now what's left, the purple thing, is a quadratic that is not factorable. And that's why we went back and revisited the quadratic formula for a couple of days. Because now, in order to find all of the zeros, I can't just bail and say, well, I'm sorry, Mr. Purple, I can't work with you. I can say, I will work with you because I am now empowered to solve any quadratic equation in the universe. And I mean any. So having said that, let's now go through and work the quadratic formula on the purple thing. What's A? 1. What's B? What is C? Good. So we're going to plug it into our little negative B plus or minus blah, blah, blah thing. Let's get rolling. So here we go. X equals the opposite of B, so negative 1, plus or minus the square root of 1 minus 4 blank blank, all divided by 2 times 1, which is, right, I'm going to go backfill my A and my C with a pair of 1s. Good. And then you're in high school, and I gotta watch when I say stuff like that because it almost sounds like condescending or demeaning. But I feel like I'm within my rights to say this. You're enrolled in an 11th grade math class. You should not be messing up the math inside of that yellow bubble. Take it or leave it. I'm sorry, you shouldn't. It is what it is. So what I see is that there are no more negatives. So the minus is not going to switch to plus. What is 4 times 1 times 1? And what is 1 minus 4? It is all day -3. So having said that, then we can now say that we've arrived at this point right here. X equals -1 plus or minus the square root of -3, all divided by 2. What's wrong with that answer? Yeah, we can do better. Instead of writing the square root of -3, how about we write -1 plus or minus I root 3, all divided by 2. Do you see on the television right now 3 answers to this problem? You should. Wanted to make sure you wouldn't say no. This red box up here contains, the white box up here contains 1 answer, right? How many answers does the red box contain? It contains 2, right? And so one of the answers in the red box is -1 plus I root 3 over 2. And the other answer is -1 minus I root 3 over 2. I want you to see something real quick. I'm going to go over to Desmos and I want you to check something out because this will be your first real glimpse at imaginary solutions. First, I have to open up my internet and this thing has to get out of my way. So if I go over to my little input box and I put in x cubed minus 1, how many times does that graph interact with the x-axis? Once. Notice that, you know, from this point on in your life, being a 0 doesn't imply that you directly interact with the x-axis. You become more of a solution to the equation rather than like an interacting point. So the graph crosses right there, you can obviously see at 1. And that is, of course, expected because when we did the problem, we got a real answer at 1. So we expect interaction at 1, but we don't expect interaction at these because we can't see them. They're not in the real plane. We can't look at them and say, there it is. So they're mathematical solutions, but they're not points on the x-axis. There they are, all 3 answers. So if someone walks up and says, like, I'm going to, on the worksheet, find all zeros. I'm not going to put all rational or all real. I'm going to say all zeros. You found them all. Their names are 1 and -1 plus or minus I root 3 over 2. Good. All right, let's do another. So I'm going to keep the theme consistent for the first 2 just to make sure that we're all okay. And then we're going to, the last ones will be a little different. So next one is f of x equals 8x cubed plus 125. So I thought for the sake of consistency, let's do one more of these. What is this? It's a sum of cubes, but they're definitely cubes, right? So this is a short set, long set problem. Recognize that so you don't have to use, you shouldn't use the rational root theorem when you don't have to. It's annoying. It's cool, but it's annoying. So what's my A value for this short set, long set problem? It is 2x. Good. What is B? I see you're a little rusty with your cubes, right? A is 2x and B is the cube root of 125, which is 5. It's been a while, I suppose. Huh? Maybe I kind of took for granted that that would still be fresh in our minds. So when we short set, long set this bad boy, what's short set going to be? Perfecto. And then let's go long set. Watch out. What's this going to be? 4x squared. Good job. Minus 10x plus 25. So as you're going to see, and there's a few, I think there's 3 of these on the assignment. Well, 4. 4 of the problems are cubes. So on 4 out of 10 problems, you're going to see cubes where you predictably factor it down. Short set will produce the real answer, or excuse me, short set will produce the rational answer, and then long set will either produce a real irrational or an imaginary. Short set's always, or long set's always going to give us crapola, just FYI, right? If it's not factorable, it's giving us junk. Sometimes the junk is on the x-axis, sometimes it's not. Let's see what this one does. Let's see where it takes us. So first off, let's talk about red set right here. He produces a very obvious answer. I hope it's obvious. What is it? Nice job, Sutter. Negative 5 divided by 2. Remember, it's a sign change, and then you just stick 5 over 2. So that's going to be the one that we are sure that at that point, the graph will slice through the x-axis at negative 2.5. Right? We could go graph it right now and look at it, but that's who you know it's going to happen. So our concern now is what can we pull or pry out of purple set? And so purple set is a quadratic formula. It's not, remember, like I said this before, and this might mean more to you now, long set is not factorable. So don't waste your time trying to factor him down. Just jump right in and just know you got to use the quadratic formula. What's A? What's B? What's C? And we're off. All right, so let's plug all that junk in and see where it takes us. So we're going to have x equals what? 10 first, right? Remember to start with the opposite of b. So we have 10 plus or minus the square root of, here we go, nice long square root sign. 100 minus 4 blank blank all divided by, good job. 2 times 4 is 8. Take a moment, usually about a half a second or 2 seconds, whatever, and then go back, let your brain reset and backfill A and C. What goes in for A and C? Can you already tell based on the discriminant if they're going to be real or imaginary? What are they going to be? 100% imaginary. Because like I'm starting with 100. Remember, the discriminant is inside the square root, and I'm subtracting more than 100. So if I go negative in the discriminant, then these are not x-axis touchers. Okay, you're not going to see them. So when we head over to Desmos in a moment and graph it, you'll see that same, the thing as last time, where you see it interact at negative 2.5, but you won't physically see it do anything at the others. Okay. So let's finish this off. What is first off, this is going to stay a minus, of course, right? So the way I would do the math, so I wouldn't have to use a calculator, is I would do the 2 in the yellow first. What's 4 times 25? And then 100 times 4 is 400. Like I'd always rather avoid a calculator because everyone knows 4 times 100, but most people don't know 16 times 25, right? So it's easier sometimes to move them around. And what's 100 minus 400? Okay, so let's take a gander at where we're at. We're at x equals 10 plus or minus the square root of negative 300 all over 8. And we've been practicing this now for a couple of days. We should not feel okay with that. What do you do with a negative 300? Yeah, that's perfect work back there. So remember, you break him kind of off to the side here. You break him into the square root of negative 1 times 100 times 3. And the 100 is the gold mine there. That's where we get our big, big jailbreak out of. So our answer in its final form, I think, no, it's not going to be a final form. It's going to be 10 plus or minus 10I root 3 all over 8. And why is that not a final form? Yeah, take the Dorito and divide all the numbers inside of it by 2, which produces x equals 5 plus or minus 5 I root 3 over 4. Is everyone comfortable so far? Okay. There's going to be a lot more today, so just be. This is one of those days where you probably won't get a ton of time to work, but you're used to that. And then Monday and whatever else we'll do more. We'll have work time. So everybody good still? All right, so we're going to transition over into something significantly more difficult. Um, you might look at that and think, "Why? That's not that hard." What changed like right away? There's 4 terms now. What else changed? It's grouping, if anything. What else changed?
It's not
Right. I mean, so we've obviously changed from sums and differences of cubes into a long 4-term polynomial, but you still haven't answered my question. Of massive significance, what changed? It's not factorable. And that's a big deal. And you can already tell that it's not factorable by just imagine, first off, you'd look for a GCF, there isn't one. And then if you built a wall down the center and just followed your instincts and said, I'm going to group this bad boy, then you can't. You should realize right away that if you pull out x squared, you're left with x minus 8. And there's no way in heck that the right. Orlando Corral, can you see Orlando Corral? And there's no way that when you do the right side and you pull anything out, yeah, pull out a 3 if you want. I don't care, but you're not going to get it to match the parentheses. So what changed? You guys hit really good things. Yeah, there's more terms, the exponents changed, blah, blah, blah. But really what changed is that factoring is off the table. So let's get to it. If factoring is not an option, are we screwed? Of course we're not. What do we do? Yes. And before we do synthetic division, what do we do? We find all possible zeros using the rational root theorem. So I hope you're seeing in an example like this how everything in the last few weeks is just coming full circle here. I'm good enough at factoring that I can recognize that this cannot be factored, and I'm good enough now at all of the requisite skills that I can do this. Let's make a list of everyone who's a possible candidate. And by the way, I am not going to give you any problems where there's not at least one good route to get you started. I'm going to always give you enough information to let you chip away at the stone down to the point where you recognize something that you can work with, okay? This polynomial in its current state is junk. It's a mess. But if I could maybe chip a layer off of it, if I chip a layer off a 3rd degree, what do I get? A 2nd degree, which is called a quadratic, which we can solve any quadratic in the world with the quadratic formula. So if we could just get a layer off, and that's where the rational root theorem pops in and says, let me help you out. So the number in the back is 15. The number in the front is 1. And if these won't have any fractions. I can't say the same for the next one, but this one won't have any fractions. And so the factors of 15 are 1, 3, 5, and 15. And the factors of 1 are just, well, 1. And so we don't have to worry about the fractional aspect. So our candidates are positive -1, positive -3, positive -5, positive -15. And this is where you'll remember this from a while back, as a team, sort of divide and conquer and get in there and say, okay, my numbers, I'm setting them up for synthetic division. There are no missing terms. So I have 1, -8, positive 18, -15. Draw your little line, leave some space, and prepare for trial and error. Tristan has said, let's try -5, and I'm totally fine with that. I really don't care what we try. So let's do this. Drop the 1, -5, multiply -13, multiply 65. I really don't think I like where this one's headed. Okay, you want to try +5? Oh, okay. Cooper has spoken with authority. He says 5 will work. So let's put in, so drop the 1. 5 times 1 is 5, -3. This one feels good. This one has a nice vibe to it. Anytime you can sort of loiter around 0 and keep it kind of level, is those have better vibes to them, right? 18 minus 15 is 3, and sure enough, Cooper tells no lies. The fact that we got a 0 means we have now found a solution. What is the first solution? X equals 5. And the beauty is that whereas before, I said this earlier, before I would have given you numbers down here, 1, 2, 3, that would have factored. But now we took that detour into quadratic formula land and have emerged now more powerful on the other side. I'm not scared. I don't care anymore. I look at them and go, gosh, I can't factor x squared minus 3x plus 3. I don't worry about that. I just set it equal to 0, hop in, do the quadratic formula. What's A?
1.
Nice. What's B?
-2.
Yeah. What's C?
+2.
Absolutely. Now, no mistakes, okay? I mean, I say that and I make a fool of myself because I make mistakes. But remember, our mission is no mistakes, nothing garbagey, nothing rinky dink. Let's see if we can get through it unscathed. No stupid stuff like 3 squared is 6. No forgetting signs. Everything. Let's do this. So what goes first? X equals what? The opposite of B is 3 plus or minus what? The square root of 9 minus 4 blank blank all over 2 times 1 is 2. Take a break, reset your brain, go back, backfill your A and your C with a 1 and a 3. Is my minus going to change? No, not this time. So I'm again going to be in the land of imaginaries. And so I'm going to wind up with 3 plus or minus the square root of, what is 4 times 1 times 3? And what is 9 minus 12? So my answers are, remember we earlier got x equals 5, and then we can put comma, x equals 3 plus or minus I root 3 over 2. Put a big old proud box around it. There you go. Okay, you ready for round 4? You feel good still? If this seems easy to you, you should pat yourself on the back, whether that's literally or figuratively, because things like this aren't easy unless you work hard to obtain a lot of skills before this. So if you're feeling like it's easy, be proud of yourself, because it wouldn't be if you hadn't done so much dang work. Yeah, Javin. You can't take a square root of a negative number. It's imaginary. So the I takes the place of the square root of -1, so that we can take the square root of a negative and just think of it as the square root of a positive. But the I makes it clear that it's not real, like it's not really there. Okay. Ready for number 4? This I thought was the hardest. When I was writing these out, I thought to myself, this will be the one that tests us the most. And then after this, I think you're going to be okay. So 3x to the 4th plus 22x to the 3rd minus 14x squared minus 7x. Good job, Ellie. Good making me proud. It has a GCF, and you don't want to walk past that. You should now more than ever appreciate a GCF like this, because it's going to give us a freebie. You really come to appreciate free points. And I look at this and say, whoa, this, and this can all be divided by. I love that. And if I can pull out a GCF that actually has a variable in it, that is free money. Now, let's rewrite the problem. So we have x times 3x to the 3rd plus 22x squared minus 14x minus 7. And what answer do we get out of that red x? Gorgeous. 1 down. I'm telling you, there comes a point where you really, really will say, nice. Now, we're right back where we were before. We have a 4-term polynomial that your first instinct is should be, can I factor this? Could I, at this point, I've already milked all the GCF out of it, could I build the wall and group it? You could try. It ain't going to happen. So like your GCF of the left side of the purple wall is x squared. That's going to leave 3x plus 22. And then your GCF on the right side is -7. It's going to leave x plus 2. Yeah, it ain't happening. So grouping isn't always meant to be. But there's light at the end of the tunnel, and it's called the rational root theorem, right? So here we are again. The number in the back is 7, and the number in the front is 3. So let's do this. The factors of 7 are what? The factors of 3 are what? Okay, so this is a pretty short list, right? This isn't going to be like that problem 4 on that worksheet that made Cooper want to come to my house and kick my dog. This is minimal, right? Um, so here we go. I'm going to start with the 1. Be organized about this. Positive, negative 1 over 1. Positive, negative 1 over 3. Okay, on to the 7. Positive, negative 7 over 1. Positive, negative 7 over 3. So that's 8. I mean, that's 8, and that's a small problem, right? So let's prep this for synthetic division, and let's head in. And again, let's work as a team. And let's pry out the one that was meant to be found, the one that wants to be found. So the numbers are 3, 22, -14, -7, set her up. And where do you guys want to begin? You say that with the tone of a man that's already tried it and knows that it works. Or, okay, let's get in there and let's get our hands dirty. Corbin has said, let's try a third. So I'm going to drop the 3. What's a third of 3? And what's 22 plus 1? What is a third times 23? It's 23 thirds, right? Remember, don't make a math problem out of something like that. When the fraction and the number don't agree, just stick the bottom of the fraction on the bottom of the hole. And say it again. Oh, yeah, you could also think of it as 7 2/3 if you wanted to. And then add -14. Can you already see why this is I've asked you this before. Why can't this work? Yeah, and it's not because it's a fraction. It's because when I add these two numbers in the red box, just generally speaking, what will I get? I'll get a negative. And right here, what's a positive times a negative? And a negative and a negative can never cancel to make 0. So we already know that that one is going to go ahead and be a bye-bye. But bad news is, didn't work. Good news is, it's one less thing we got to worry about. Did anyone find the magic number yet?
Yeah.
So -1/3 from what I'm hearing is a winner. And this is where you remember this. You've done this before, where we pair up and work as a team. So I trust you guys, but let's do it anyways. We need the numbers. So like just the end product is cool, but the residuals that we get along the way are what we really need, right? So I got 3, -1/3 of 3 is -1, 22 minus 1. This is feeling better, right? When the fractions and the whole numbers play together nicely, it feels good. Like I'm on a roll. -1/3 of 21 is -7. -14 and -7 make -21. Jackpot. A negative and a negative make a positive. A third of 21 is 7, and booyah. There's our 0. So going into this problem, how many answers have we now found? You guys are amazing. Yes, we've found 2. Their names are 0 and -1/3. And beautiful. We have peeled 2 layers now of the onion off, revealing where we can always find success, and that is quadratic fill. So these numbers down here that I'm underlining in white, they're our treasure, right? At some point, they're just a math problem. For us now, they're just a means to an end. So the 3x squared plus 21x minus 21, set it equal to 0. Oh, let's see who answers this question right. What do we do now? Ooh, there it was. Bam! If you don't see the GCF, you're going to hop into the quadratic formula using 3, -21, and 21, or not in that order. Not us. We're going to look at these and give ourselves a break. And look, these 3 numbers that I'm putting check marks on can all be divided by 3. So take advantage of that. That's awesome. So that drops my equation to x squared plus 7x minus, oh, I would way rather do the quadratic formula with those numbers. All right, let's get to it. What's A? B? C? Okay. All right, let's get to it. Quadratic formula says that x equals what? the opposite of 7, gorgeous, plus or minus the square root of 49 minus 4 blank blank, all divided by 2. Backfill your blanks with what? So for the first time in today's lesson, if I point to this minus sign with a yellow arrow, what will you say? It's going to switch to a plus because it's going to encounter another negative. So I'm just going to cut right to it and just say, screw this. Like, I'm not going to make this harder than it has to be. I'm just going to do straight up 49 plus 28, right? It's what it really is. What's 49 plus 28? It is indeed 77. So x equals negative 7 plus or minus the square root of 77 all over 2. How many answers have we now found? Nope. We have found 4. Remember that in this white box, there are 2. Will these ones actually be on the x-axis? Yes. Why? Because they don't have I. They're not imaginary. They're physical, tangible locations on the x-axis. And if you're interested, I'll show you what I mean. Are you interested?
Yeah.
Good. Got a calculator? Anybody? I can use mine if you want. I don't care. I'm going to write something in purple. And I want you to type that into, I did not put plus or minus. I just put plus. If you have a cal, and I'll do it along with you. So let's make sure we all get the same things. I'm negative 7 plus the square root. I'm getting 1.77496. So everybody, if you have that on your screen, 1.774964387. Now let's take and divide it by 2. So divide that answer by 2. What do you get? Ready? I'm almost done with you. Some of you might not even be interested in this. You're like, God, I wish this guy would shut up. But I hope what you're about to see is actually pretty rad. I hope you you don't have to audibly say something like, whoa, but I hope you have a moment where you might be inclined to feel that way. I'm going to go over to Desmos. Surprise, surprise, right? And I'm going to type in the original problem, but I'm going to move coffee over onto Baby Yoda first. Here's my graph. So we knew that 0 was going to be nice, right? Who else did we know was going to be nice? A third, negative a third, right? So if I go back to Desmos now and I zoom in on negative a third, Desmos won't show this to me as a third, but you recognize that point right there as a third, don't you? Negative a third. Those are called rational solutions. The ones that I think are totally rad are the ones that we've never talked about before, the irrationals. Remember how just now we got 0.887482197 when we actually computed one of them? Check this out. Watch what happens as I zoom in on this point. This is what irrational means. I mean, it's not what it means, but this is a pretty cool way for you to visually kind of get your head around what does this mean. Every time I think my point's going to go towards a grid line, look at what keeps happening. It just can't find it. Do you see that? I zoom in a little bit and I think, and this is as far as it'll let me go, but when I hover on this, you see that decimal? 0.8875, exactly as predicted. So that's what the irrational solutions are all about, is that they're there, they're physically there, they're just not the kind of numbers that we can ever really get to. It's pretty rad. Is that neat for anybody other than me? Was that cool for you? Do you like noise? Watch this. Boop. That's what the graph looks like. And the other one, by the way, is over here. So if we had done -1 or no, 7.88748219. And there it is right there. So I think that's so amazing that we can still find them, but we can't do it through conventional like factoring means. We got to bust out the big guns. This is the best website. I mean, it's not the best website, but it's nice. I would just like a website that had nothing but funny cat videos. Like, is there a place called like funnycatvideos.com? If there's not, one of you guys should make that and make some bank. Over there playing on your phone, you could use that phone to start a website, funnycatvideos.com. All right, last problem, guys. I just threw this in here because I think there's going to be one of these on the assignment. And honestly, even if there's not, this is a total softball. After what you just sat through and did, this one is stuck up on a tee and just saying smack away. This is light work. What do you notice right away? Massive GCF. This is great. And not only does this GCF give us an answer, he's like, who's the man? I'm going to give you two answers because the GCF is x squared. And if I can pull out double x's, that's peeling two layers off the onion. What does that bring me down to? Very good. So right out of the gate, look at this. I'm going to put two check marks under that red because he's like, boom. Like, who's got your back? I do. I'm going to give you the answer x equals 0, and it counts for 2. So you're down to quadratic fill just like that. So this again, let's for the sake of getting this done, let's not leave anyone hanging. Let's finish. What's A? What's B? What's C? Dope. Here we go. All right, let's get in and quadratic formalize this thing. That should be a verb, to quadratic formalize. All right, so x equals what? Plus or minus 49 minus 4 blank blank all over. And in my blanks will go 1 and 2. Real or imaginary? Very, very real, because inside in the discriminant, I have 49 minus 8, which last I checked is a pretty positive number. So if my discriminant is positive, the answers will be on the x-axis. So I have 7 plus or minus the square root of 41 all over 2. And if I wanted to make a full comprehensive list, I could write this. This would be the math professional way to write this. I would say x equals 0, and then parenthetically, I would just put a little, remember this, x2 to show that it's times 2. And there it is. And that would it, I'm sorry, it would do what, did you say? Yes, it will bounce at 0. We can see it if you want, but yes, it would bounce at 0. And then it would cross at an irrational number and cross at another irrational. Fantastic. All right, that's it. I'm going to hand you out this pretty dope worksheet, and you can work for 13 minutes.